Hydrogen. We all know that it's going to play an important role in our sustainable future, but it's not without our challenges. My name is Matthew Laskaj. I'm the Chair for the Institution of Mechanical Engineers Scottish Region and Director of Project Engineering Management Limited, a specialist engineering and training consultancy. Today, I'm joined by three industry experts who are going to talk to you about the hydrogen economy, the project, technical, and commercial challenges. Coming up in a little bit, we've got Johnathon Milsom and Mike Hurley from TP Group, who are going to talk about the potential of hydrogen as a replacement fuel and how it would fit within the mix to deliver the 2050 net zero targets. But first, I'd like to introduce to you Tim Podesta. He's going to talk about turning promises into deliveries. He's going to share his top 3 examples and stories of practical development of the hydrogen economy with a focus on the UK and Scotland. Tim's a subject matter expert in project shaping, front-end planning, and investment analysis. He celebrated 35 years with BP in 2016 after completing a number of leadership roles in technical, commercial, project, and program management. He's currently an independent consultant and faculty member of World Hydrogen Leaders, presenting a course on the investment case for hydrogen. So I think he's pretty well suited to talk about the next topic. Welcome, Tim.
Matthew, thank you so much for that very kind introduction. And thank you also to PMI UK and PMI Toastmasters, who've helped me prepare for this and given me the opportunity to share my passions, my experience, and my hopes for the future. Now, COP26 is very soon happening in Glasgow, but I want to take you back to COP21 in Paris in 2015. And what happened there? 192 countries got together, made declarations, they made promises. And what's going to happen in Glasgow in a couple of weeks' time? 192 countries are going to get together, make declarations and make promises. My belief is, as engineers, project managers, and as citizens, our duty is to turn those promises into deliverables. And particularly as project managers, we can help with the planning and the delivery of those plans. Now, as we look to the future, I have a wish for the climate for COP26, and it's not a nebulous thing I'm going to put a penny in a wishing well. My wish stands for wind, solar, and hydrogen, where wind and solar are renewable energy sources for electricity. Electricity can be converted to hydrogen through electrolysis, and hydrogen can be a source of energy and fuel and stored fuel for the future. Now, I've got 3 examples I want to share with you of practical things in terms of projects and technology that are happening today, actually in the UK, in Scotland. The first one is related to the community around Orkney. The second one is based in the north of Scotland in the Highlands. And the third one is in Glasgow, the city where I grew up. So where I'd like to start is by showing you a diagram of a place which is close to my heart, because I actually started my engineering career and in projects and commissioning, worked in the Shetlands. Now, this is actually the Orkneys, which is very similar in terms of character and culture, but different. And it's off the northern coast of Scotland. And what they've done in the Orkneys is they've turned access to energy, wind and wave and tidal in particular, into electricity and then into hydrogen. Partly driven through necessity, because to access energy it's quite difficult in the island and remote communities, but also through opportunity. You can see here the pieces of the jigsaw they put together. Community wind turbines, tidal turbines. There is the opportunity here that they've taken to capture the energy for waves and tides moving from the Atlantic to the North Sea and from North Sea to Atlantic. 2 megawatt turbines are in play. They've created hydrogen and infrastructure where they've stored that hydrogen, transmitted it. It's been used in transport, in marine, and in industrial, and in homes. All put together it's like it's doing a test bed, and it's actually seen as a test bed for the future because it's operating today, and they're investing right now. That's the first example. The second example, coming a bit further down the UK to North Scotland, is around Cromarty Firth. And at Cromarty Firth, they have a grand scheme and vision based around the port to be a centre for two things: for the offshore wind, massive developments opportunity. Scotland, the UK, is one of the windiest parts of Europe, so why not make use of that? Converting that electricity onshore into hydrogen, green hydrogen. A multitude of potential uses, but in good project process, they've been looking at the feasibility and the concept for using hydrogen as a source of heat, as an alternative to LPG and other gas. And what can you imagine they make in the Highlands? Whiskey. And the project, which has been through feasibility, good project process, are moving into the front-end engineering design, the detailed scope development for a final investment decision on the basis that they have a technical case, commercial case, and that they will need some political support as well. So that's the second example: green hydrogen producing net zero whiskey. I'd love to have the first round. Then the third example, moving further down, closer to COP26, is related to using these things, these wind turbines. Now, this is over 500 megawatt, several hundred wind turbines, very close to Glasgow. The biggest onshore, one of the biggest onshore wind farms in the UK, generating today. And being a windy part of the world, what happens? 20 to 30% of the time, these turbines have to be turned off because the wind is generating so much electricity that it cannot be used. The network doesn't need it at that moment. It's called curtailment. The opportunity is, well, we should be able to use that even, and the initial pilots use a small part of that, 20 megawatt electrolyzer, to create hydrogen. That hydrogen is going to be used in transportation, and it can be used in buses. Initially, there's a plan to have several hundred buses running in Glasgow, and particularly in the route between Glasgow and Edinburgh. This is the heartland, the central belt of Scotland. Between point B and point A here, it's about 50 miles. That you can imagine that there's a lot of transport runs on that route, over 500 bus journeys a day, and they could all be consumed or used, fuel cells converting the hydrogen into the motive power for those buses. In and around Glasgow as well, alongside electricity, hydrogen use in transportation has particular use where it's most valuable. Long distances where you want recharging or the refueling needs to be equivalent to as if you were using hydrocarbon. You won't be able to use those buses or those trucks most of the day, and you don't need to be sort of stopping for batteries. And then, of course, you will need the time for recharge. So that's where the place hydrogen has. That's happening in Glasgow, place where I grew up, and it certainly is a city of the bus. I've got many memories of going in and out of Glasgow on the bus, going to school, going to sport, and going to concerts. Some of the best concerts I ever saw were in Glasgow. I remember going to see Queen there in the early days. Coming home on the bus, my ears buzzing with the music. So coming back to summarising what I've shared with you, quick tour of Scotland and of hydrogen. These are schemes which are happening today in terms of projects. They've been through the proper process. They need engineers to deliver as well. So in summary, COP26, turning promises into deliverables. Hydrogen has a part to play. I encourage you to have a closer look at some of those three examples. If you just Google Orkney hydrogen, opportunity Cromarty Firth, or green hydrogen for Glasgow, you can find out more about what's happening today. Thank you. I'll hand back to Matthew.
Wow, thanks very much, Tim, for sharing all those experiences, that information. Really interesting. I can see you're passionate about hydrogen, so I've got a question for you. What about the alternative energy for a net zero world, which is renewable electricity?
Thank you for that question, Matthew. When I think about hydrogen, I think almost at the same time about the alternative, which is renewable electricity. They both need to go together. Hydrogen comes from renewable electricity, particularly when it's green, and then hydrogen can be turned back into electricity. In fact, while I was listening recently to Spencer Dale, who is the chief economist for BP, and he was asked a question about what he saw as the future mix of energy in a decarbonised world. And he said, well, about 70% electricity and 30% hydrogen. They both go together. So for me, it's not either or, it's both.
Fantastic, Tim. Thank you very much. Really informative and interesting take and perspective on the hydrogen economy. All right, fantastic. We've got next speakers up. We're going to be talking about the potential of hydrogen as a replacement fuel and how it will fit in with a mix to deliver the 2050 net zero targets. So I'm pleased to welcome two speakers for this session. We've got Mike and Jonathan from TP Group. They've got over 50 years of experience in delivering hydrogen and atmosphere management solutions within the defence industry. The TP Group is internationally recognised for their products and services for the most demanding of environments. They provide systems integration experience and expertise, consultancy, and exceptional safety and reliability, and are also in projects to develop hybrid, electric, and hydrogen-powered aircraft. Jonathan is the Capability Director for the TP Group Consulting Business and IMechE Western Chair. He's got a background in cost engineering, and he's applied his expert P3M and engineering skills to a number of major programs within the maritime defence domain, including Dreadnought and Type 26. He recently led a team that baselined the total fossil fuel usage across all of the defence to the year 2040. Mike Hurley is a qualified engineer and industry professional. He's got significant involvement with new innovative technologies in telecoms, IT, smart cities, green tech, and cybersecurity. So welcome, Jonathan and Mike. Thanks for joining us.
Thank you very much, Matt. I'll share my screen.
Yep.
Good afternoon. We're both delighted to be able to talk to you today about the hydrogen economy and the project technical and commercial challenges about this. We will discuss how hydrogen fuel will help with delivering the 2050 net zero targets. How would this reduce the carbon footprint within defence? So to introduce yourselves, my name is Jonathan. I'm the Capability Director for TP Group for the consultancy division specialising in cost engineering and P3M. I'm a chartered engineer with a Masters in Engineering from Warwick University. I'm also the chair for the Western region of the IMechE. I've been working on cost management and business cases within the defence industry for the last 10, 12 years, working on Cat A programmes of multi-billion pound values, including Type 26 and Dreadnought.
My name is Mike Hurley, and I'm really pleased to be able to talk to you today on this subject. I am the Business Development Manager for Green Energy at TP Group, and I've always worked in new, innovative technologies and high-tech growth areas. Jonathan, maybe you can describe the work we have already done regarding fossil fuels.
Thanks, Mike. I'd first like to kind of discuss around defence accounts for about 50% of the UK central government's emissions. So the Ministry of Defence has an important role in meeting these net zero targets. The Ministry of Defence has a climate change and sustainability strategic approach already, outlining the first steps to delivering the 2050 net zero targets. But can you believe that the defence accounts for 50% of the UK emissions? TP Group have been working with the Ministry of Defence to baseline the fossil fuel usage between 2020 and 2040 across all domains, including Army, Navy, and the Air Force. We have successfully been able to model the future demand of fossil fuel usage across all defence equipment, platforms, and buildings. This baseline will now allow for the modelling of the transfer away from fossil fuels to sustainable fuels and technologies going forward. This work into baselining the fossil fuel usage has outlined and shown there are thousands of pieces of equipment and vehicles using various grades of fuels across all of the defence arms. With these pieces of equipment and platforms having different supply chain routes, and storage, this leads to a very complex scenario to solve as we move towards more sustainable and renewable fuels and technologies, each requiring different management. The diagram simply illustrates how using fossil fuels and that exchange to renewable fuels or technology will not happen overnight, and there are some significant challenges. We therefore need to understand all the potential options to reduce the amount of fossil fuels, whilst understanding the creation, storage, and transportation of new and sustainable fuels. The defence industry is going to have to investigate all sustainable fuels, and one of the most potential options is hydrogen. Mike, what do you think are the challenges of developing and using hydrogen as an alternative fuel?
Thanks for that, Jonathan. Well, TP Group has great experience building electrolyser equipment, using electricity to break water into hydrogen and oxygen in a process called electrolysis. But to make this totally a green solution, the electricity needs to be generated from renewable sources. And we need to find additional ways to do this. As a leading example, the MOD is the second biggest landowner in the UK, and the Army is already planning to build 80 solar farms. The green energy from this can drive a whole ecosystem on sites. If we look at the railway industry to meet these targets, the challenge is to remove all diesel-only trains from the network by 2040. It's amazing that in the last 3 years, we have electrified 700 miles of track, some 36%, and we now need to get to 86%, around another 8,000 miles. With the huge costs and impact with construction, hydrogen should be considered as a scalable alternative. To reach these targets, everyone will have to get involved. Local communities, campus sites, to generate power locally using renewable sources, such as hydrogen electrolysers and storage. Because, to put it in perspective, with electrification and widespread adoption of electric vehicles, the electricity grid centrally will not be able to cope. As I mentioned, hydrogen is not the silver bullet, but what it can do is help the environment by repurposing the existing vehicle fleet and also diesel trains to save on electrification. We need to swap out the diesel engines for fuel cells, batteries, and hydrogen storage. To understand the scale on the problem, it's unbelievable to see in London that diesel generators are used on over 5,000 building sites, which causes more than 14.5% of the most dangerous form of diesel particulate. Jonathan, what would be the impact of repurposing the fleets have within the defence sector?
Jonathan, I'm not sure if you're talking and you might be on mute again.
Stop again.
Yep.
Thanks, Mark. The defence industry must explore repurposing existing equipment and platforms, given the constraints and budgets within the defence industry. The repurposing of existing fleets using hydrogen fuel will be one way of maintaining high capability without a significant increase in cost. Sustainability targets, or the net zero target, can only be reached and met if we have a clear understanding of the complete landscape. For example, supply chains. This includes the development, transport, and storage of fuels, but also looking into the disposal costs of equipment going forward. However, there still needs to be a substantial amount of investment to develop the infrastructure to support hydrogen as a fuel, and even the transition to other sustainable fuel types. As we move forward, the traditional metrics of measuring cost against capability is now going to be made even more complex with the addition of sustainability as a third metric of success. Traditionally, business cases have been measured by cost and capability in the form of a combined operational effectiveness investment appraisal, and this will now have to include the element of sustainability going forward. The constraint on Ministry of Defence budgets compared to that of some private sector domains will mean project managers will be key, as there will be a closer scrutiny of the capability versus sustainability going forward.
So Jonathan, I've just got a question for you, just if I can just jump in and interrupt your slide there. Since it's now not just capability versus cost, but it's capability versus cost versus sustainability, do we have to tolerate a drop in capability from what we would expect?
Thanks, Matthew. That's a really kind of key question. And I think, yes, we probably may have to look at a drop in capability if we want to maintain the kind of sustainability and cost targets that we've got. However, that can't always be, the case. We do need to maintain a high capability. So we also need to look at, do we keep that high capability and reduce the fleet size, or do we take that knock on that capability to maintain a larger fleet size and availability? I mean, it emphasises how much that budgets are really important to this, and that we need to invest more in this sustainability target to meet that net zero 50 and maintain a high capability for our defence industry going forward. With cost being such a big constraint on the capability element, it will include reviewing the regulations of hydrogen as well, and the fuel and the safety impacts. Mike, could you explain this challenge and any other key challenges that might need to be addressed?
Thanks for that, Jonathan. There are a few key challenges in order to make this happen. We need regulation on the use of hydrogen, which will improve safety and reliability. We need training to transfer the skills from other industries such as oil and gas. Moving to renewable energy will also come at a cost to meet these targets. Investment in mass-scale production will help drive down the technology costs and improve the delivery times. Innovative ideas are also required, like using industrial ports and turning them into refueling hubs. Hydrogen shipping routes also need to be in place to kickstart the international trade. For example, Saudi Arabia is already building a $5 billion plant to make green fuel for export. A technology mix of renewable solutions is required to meet these net zero targets. And I'm pleased to say, for the first time last year, renewable energy generation took over fossil fuels, with renewables producing a record 42% of UK power compared to fossil fuels generating 38%. And we need to continue the drive on this. What are your thoughts, Jonathan?
Thanks, Mike. Yeah, the move to greener energies is key within the defence industry. And there are large amounts, as you've described, solar panels, solar farms being installed on defence estates around the country. And again, this excess electricity from those defence estates can be used in the electrolysis process to generate more hydrogen fuel at each of those estates. And when we're talking around fuels, traditionally there is a theory that for every 1 litre of fuel on the battlefield, it takes 10 litres of fuel to get it there. So for addressing that fossil fuels usage, we can look at that supply chain and the amount of fuel that it takes to get that to the battlefield. There'll be a really good area to start and look at reducing that demand on fossil fuels and fuels, and using hydrogen and other fuels. We can reduce that footprint by over 50% and start to work towards meeting that net zero target. Therefore, looking at supply chains and how we manage the distribution of fuels will be key area to address going forward. Defence needs to consider that mix of renewable fuels and technologies, including hydrogen, but must make use of other sustainable fuels and technologies across their equipment, battlefields, and their logistic processes. There is a challenge on the amount of investment, again, within the Ministry of Defence as we undertake the initial reviews as per the climate change strategy released. There is a need for everyone to be working together here across all the defence arms as an industry, with primes as well. And there are other industries, as we've discussed today, automotive, the rail, the air industries. They've all made significant advancement in this area, and we need to capitalise on that. TP Group can work with industry to improve the understanding of cost budgets with effective modelling of technologies. As we've discussed, this is all about joint collaboration, and we at TP Group look forward to helping in any way we can and joining you on the journey to meet these targets.
All right, thank you very much, Mike and Jonathan. That was a really informative topic of something different to what we would typically see in hydrogen. Most of the areas that people see in the news and in the media is all around about transportation and power generation and things. But looking at some of the topics you've just covered there, I guess one of the questions I'm seeing, and one of the questions for you, is where would you start? What would be the starting point for all of that?
Well, that's an excellent question, Matthew. As we're already seeing, the MOD is a leading example. They're already planning to build 80 solar farms, and that can lead to a whole campus ecosystem of renewable technologies such as refueling, hydrogen storage for peak times, and they've already made that leap of faith, which is a good step to start.
All right, brilliant. Yeah, it's always the hardest part, isn't it? Where do we start? Quite often we know what to do, but what's that starting point? So I think that puts it into good perspective. All right, well, thank you once again, Mike and Jonathan from TP Group. And also, obviously, thank you to Tim Podesta for his really interesting presentation earlier on in the session. And of course, thank you to everybody who joined in and listened to the session also. If you want to get in touch with people, I'm sure Tim and Mike and Jonathan won't mind you getting in touch with them later on after the session or in the coming days. So thank you and enjoy the rest of the presentations.